Hi there. You ever find yourself just scrolling through social media and find an interesting project and think to yourself, I can build that? That happens to me all the time. The only problem is I actually spend my money and build it. A couple months ago, I was scrolling through TikTok and found a video by a YouTuber named Philip Cook. It was basically him using light to transmit sound or information over the laser. And through everything I understood about the subject, it made complete sense. So I thought to myself, I can build that. So I bought everything I needed to on Amazon and did just that. As you can see, we have a little makeshift setup for our outdoors test. There's our laser. There's everything through in a spare pot. And there are the leads which connect to the aux cable. And then we have a switch here, which if I flip it, should turn on the laser all the way over to the garage. Next up is the test. Right now I'm on the way to the garage so we can do the test. Let's go. Before we actually get to the outdoor test, I should probably explain to you how I built it and how it all works. Okay, this is how we're going to be putting the entire thing together. We're going to be starting with the receiver. So you're going to need a solar panel, a speaker, and an aux cable. This is pretty much the easiest part. You just need to plug the aux cable into the speaker, take the ground for the solar panel, hook it up to the tip, take the hot wire for the solar panel, hook it up to the rim, and there you go. It's already working. So if you shoot signals from something like a remote, it'll make sound or with visible light. Next, we're going to put this aside for a moment and move on to the transmitter. You're going to need a breadboard, a lot of wires, mini screwdriver, amplifier, and a 220 ohm resistor. We're going to start with the setup for the amplifier. So we'll put all this to the side for a moment. You're going to need the signal wires for the amplifier. The left is the positive output, the right is the negative output. You just put these signal wires in here and screw them in. And these are the output wires. So you have two coming out, and then you need the input. So we're going to take these two yellow wires for the inputs, and they're going to go to, if this thing would focus. Okay, let's forget about that. So this one is VCC in, so that's where your voltage input is coming from. Then there's your general signal in, which will be coming from the aux cable of whatever you're bringing in. Then there's your ground and your other ground. These two go together in a pair, 1 and 2. And then you're going to need your hot wire again. And that is the wrong type of hot wire. You're going to need your hot wire in. And your ground in. Then you just hook the hot wire and the ground up to a battery. And when it's time, we'll hook this up to the aux cable that'll be bringing our signals in, which will be these. And then these outputs just go into the breadboard. We'll move this over and start with the breadboard. We'll put ground to ground and the hot to the hot. Next, we're going to be doing the rest of the setup with the laser and the light and everything. We'll first set it up with a light, and then once we got that done and have validated that it's working, we'll put the laser in. So we're going to take these, ground to ground, hot to hot, put those in. Then we're going to take our 220 ohm resistor, take it from hot, and I'll put it onto rail 17. There we go. Now we'll take the LED, put that in here. And am I missing a wire? Well, that's an easy fix. Hold on a sec. Just got to make sure the anode and cathode are in the right place. They are. So I'll take this from 19 to ground. And then we got the general power for the entire thing. As you can see, it's working now. Now, we'll take everything else and put it together. Once we got that working, we're going to grab a laser diode from the drawer that I probably should have already had prepped, but what can you do? Gonna take the LED spot and hook these up to it. We're gonna have yellow for the yellow for hot and blue for ground. Colorblind, but I can still kind of tell the difference. Let's get the yellow in there. And the blue in there. Okay, as you can see, we have our little laser. Now, we'll hook up the input and then we'll test it. Where did I put that USB-C to 3.5mm cable? Okay, I've got the cable. So now we're going to take these two input signal wires that we had for the amplifier and hook them up. This one goes here. This one goes here. We have those here. We're gonna move this entire setup over so we have some space. Probably looks like a jumbled mess. Let's wake our speaker up. Plug this into the iPad and hit play. And there we are. It's a little scruffy, but that just means I need to tune the amplifier. And it works with all types of light, so if we just hook it up to the LED, works a lot shorter range, but the reason it may sound a little louder is because the LED can cover more of the solar panel than the focused laser, but the LED doesn't work from as far away. Trade-offs. Okay, thank you. Okay, here we go. Now I just gotta make the call, and then we should be good to start. Ready?
Okay, I'll do it now. Bye.
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 Any second now, the laser should come from right up there to right here. Let's see it. Good thought I gave me 15 seconds.
Something's not right. The laser's not shining.
Push it all the way to the right. Make sure it's flicked all the way to the right.
The switch?
Yeah, all the way to the right. There's 3 positions, left, right, and center. There we go.
Oh, okay.
Leave it right there. Thank you. Okay, here we go. Let's get the speaker powered up. Volume maxed out. Check the electrical connections. There we go. There we go. That's better. Look, I should bring you guys closer so you can hear. This recording's kind of gonna suck, but it's my first try, so you gotta deal with it. There we go. The rain's probably not helping. Try it again over here. Get you up here with me? I probably should have soldered these connections beforehand, but you get the gist. It works, and I'll do a better version later. Okay, we are back from the first test. That didn't go so well, so I'm going to solder these alligator clips onto the solar panel, so hopefully we get a better signal and try it again in a few hours. Okay, I've got the new alligator clips soldered onto the solar panel. Time for long range take 2. Okay, we have everything set back up. We'll be aiming for right down there, because where we were aiming before, there are some wires that were blocking the light, and that was not fun to deal with. So now all I have to do is go downstairs and test. And it's raining again. Hopefully I get there quickly. Let's get this done. And I forgot to turn on the speaker. One sec. Now let's do this again. Speaker's on this time. Okay. I hate this rain. You might be able to see the beam. The rain's interfering, too much static. Looks like I'll have to try this again tomorrow. Okay, it's 2:14 a.m. Apparently, the rain wasn't the problem. For some reason, the minute I walked out the door, everything just broke. I rebuilt that circuit dozens of times, and then I built this one from scratch and had to rebuild it dozens of times. I think the problem is this thing right here. These amps, I think I got ones that were a little too cheap, so half of them are duds or just break quickly. But let's hope this one works. Finally. Okay, I'm gonna put this one in its own pot, go to sleep, and I'll work more on this in the morning. Good night. It is the next day, or 2 days later, depending on how you think about it, and it's time to do test 3, test 1 with the new setup. Let's hope it works. And we're here for test 3. Let's hope it works. Looks pretty good. Thanks for watching. The next part should be out in about a week or so. Have a nice one. Bye.